A04 deals with pointer arithmetic and array notation equivalence. So this is a very simple exercise that is just going to review how both notation can be used interchangeably. So you are given some code here that uses array notation on an array, and we are going to modify it first only on one spot, so that we use a pointer notation, a pointer arithmetic notation, still based on the name myArray here. So we are going to modify this notation here from array notation to pointer notation, and then we are going to modify the code more thoroughly so that we can have, like here, the initialization of a pointer, the incrementation of a pointer, and use a pointer, this time p, to make the assignment of 0 to all the content of this array of integer. Once we are done with that, here is some code that displays the content of a string working character by character using the putchar command. We are going to replace it by an approach where we use a pointer notation once again. So let's dig in the code. I have already here the cut and paste of the code that is in this exercise sheet, plus a couple of printf here just to make things readable. And we are going to display things on the screen to facilitate making sure that everything is working. So we're going to add a couple of printf. Let's start with the first loop. The first loop should be already working. Okay, I'm just going to add here curly braces so that I can do a printf once I'm done displaying each element. So I'm going to display here %d between square bracket just for display purpose, okay, aesthetic purpose, and I'm going to display the value of my array I every time I'm done assigning it to 0 with this function. So once I'm done, there will be a backslash n here, so that should be okay. I'm going to save, and I would like to test that, so I'm going to comment everything here because it's full of little syntactical error. Okay. Remember, the version that is in the exercise sheet has like things like xxxx here to fill in the blank, so I don't want to even try to compile that. And I'm going to comment everything here so that I can save and compile just this first version, make sure it's working. I'm going back to Conqueror, gcc a04.c. Okay, couple of little glitch here. Size is undeclared, okay, and unused variable myArray. So let's go back here. MyArray is actually being used, and on the other hand, I didn't define size equal to 3. Oops. So now that I have the size, myArray definition will be accepted, which will take care of the other errors that I had here. Let's double check this real quick. Okay, this is good. Let's try to run it. Array version 1, 0, 0, 0. Let me go back to my code here. There we go. Well, I didn't initialize actually my array to anything. Just so happened here that we have 0, 0, 0, 0, so that's fine. I am going to, whoops, I'm saying like stupid thing here. I didn't initialize, but I assigned before to display. I thought for some reason I was displaying the initial content, so I assigned zeros as I was working for my loop. I display all those elements. We are good. Okay, now second version, array version 2. This time we are supposed to use a pointer arithmetic notation here instead of myArray index I equals 0. Well, the equivalent of myArray index I in pointer arithmetic is star parenthesis myArray plus I parenthesis. This is achieving exactly the same job. I am going to add once again curly braces around this code so that I can reuse this printf here each line to display the result after modifying the content of the array. So to make sure that this shows something on the screen to tell me it's working, I'm going to assign here 1. Okay, same thing for now. Let's comment everything else and work our exercise step by step. So I'm going to recompile, execute. First version displays 0, 0, 0. Second version displays 1, 1, 1 after modifying the array. It looks like this is working. We're going to now jump to the version 3. This time we need to use a pointer p, okay, instead of myArray. So initialization of p is going to be easy. Okay, p equal myArray. P points now to the first element of the array. Incrementation of p will be just as easy. p plus plus. Increment by 1, which means increment by the size of an int, which means goes to the next element in our array. Now, how do I assign something to element index I in this case, since I don't have an index anymore? I'm just using p. Well, actually I have the index, so I could write p index I. That's not what I want to do. More array, more pointer arithmetic notation, I could write star p plus I. And that would be like closer to how you would use your pointer. Except that I'm not paying attention here that I'm incrementing my pointer. So this p plus I and p index I would work only if I was not incrementing the pointer. In this case, because every time I advance my pointer by 1, I can simply instead use star p, meaning whatever is pointed by p is assigned the value, and I'm going to replace 0 here by 2 to give me something readable on the screen. To make sure that this function is working. I'm going to add my printf, enter, save, conqueror, recompile. Oh, it's a syntax error. Line 40, syntax error before the / token. Yes, it's because I didn't comment the rest of my code here. So let me go back here, and I'm going to add training printf here. Printf \n just to make sure that my displays read a little better on oops, undo by error, read better on the screen. So save again, back to conqueror. Let me see, gcc, compiles OK, runs 0, 1, 2, everything is working so far. Go back to playwright. Now we are done with all the version of our int arrays exercise. Okay, now what about strings? Well, this is some code here that is going to display the content of a string, except that I didn't initialize it to anything. So where is my constant size? Size is 3. That means I should be able to, actually I should be able to get away with not using even size and just initializing here to a string of my choice. So I'm going to try this. Let's say that the string is what are you doing in my swamp? Save. Let's go to conqueror. Let me double check first that size was not used at all. There we go. Let's try to compile this. Let's try to run it. What are you doing in my swamp? The string is displayed character by character. Back to the code. You will notice here that we use an index, okay, I equals 0, I plus plus. We do not check any size for. What we check is, while this condition is true, I keep looping. What is this condition equivalent to? str index I is the ith character in the array of character str. So as long as this character is true, I keep iterating. What does that mean for a character to be true? Well, like anything else, different than 0. So only when I encounter the character of ASCII code 0, I will stop my loop. What is the character of ASCII code 0? \0. So writing this is equivalent to write this. And you know that \0 is a character that is used to mark the end of a string. So there we go. We have a very compact way here to write things, and we keep displaying the character on the screen. Okay, that's making sense. Now, what about version 2? Version 2 is supposed to use pointer arithmetic. Okay, so instead of here using str index I, we want to find a different way to do this. Well, okay, let's define char star, and I'm going to call this s for string. I'm going to here assign, I don't even need the index anymore, so I'm going to assign s to str, the beginning of my string. I'm going to increment s by 1 times the size of a char, which is 1 byte. So this is one of the rare time where incrementing a pointer is going to lead actually to adding 1 to the address. And then I'm going to display, well, whatever is pointed to by char. So this is going to be put char star s semicolon. And what about my test here? Well, as long as star s is different than the null character. I keep iterating. Let me remove real quick this end of comment sign. We're going to compile this and check that there are no compilation error, no syntax error, then execute it real quick, and it's working just about the same way. Okay, so I'm going to put back the code and we are done with this exercise. This just illustrates the equivalence of array and pointer arithmetic notation, both in the case of regular arrays of int, could be array of double, etc., and in the specific case of array of char used as string, that is terminated by a \0 special character.